Welcome to the Generation AI podcast, where we decode the future of artificial intelligence in higher education. I am your host, JC Bonilla, joined by the very grateful Ardis Kadiu. And today we're talking about the current state of future AI models, slowdown, safety, and specializations. But before, how you doing, Ardis? Happy Thanksgiving, friend.
Happy Thanksgiving, JC. Wow, that was a mouthful, man. So it's like, you mean business.
I tweaked the intro just a tad so we can, do this. How was Thanksgiving? We're recording on the weekend of Thanksgiving. So, it's always much to be grateful for everyone at Element, much to be grateful in our family. So let's start with you. How was it? How did it go? What are we grateful for, Mr. Kadiu?
Lots of stuff to be grateful for. We had, we always host Thanksgiving. So we had a house full of people. My parents, my brother came down from New York, and then my wife's family was all here as well. So it was a good time. And there is so much food that we consumed. But I'm really proud of my turkey. So this is the first time that we ever made turkey.
And you make the turkey? That's a Ardis special?
Well, this year it was.
Oh, wow.
So guess what I did?
You fried the turkey.
No, even better.
You stuffed it with a duck and a chicken?
No, I haven't gotten to that.
Remember, I do have some of my background is from Arkansas, so I've experienced the what is it called, the Tudorcan chicken stuffed turkey.
Yeah.
So tell me, what did you do?
We did. So what I did is we smoked it. So we had smoked turkey. So
the smoke. It's a big smoker that you have, my friend, right? So how big is this bird?
I have the green egg. So I have the green egg smoker, and it barely just fit, right? Wow. So like we had to change a couple of containers, like a couple of holding. So it barely just fit, but it was there for 6.5 hours. It's probably the best turkey because I'm not a big turkey fan.
Right.
I mean, I have it on sandwiches, cold cuts and stuff like that, but I'm not like,
I hear you.
I don't go out and ask for a turkey on the restaurants, and my wife is not a big turkey fan, but this was so good. So I think this is it.
Talk to me about the pre-smoking game. So did you brine it? Did you do any prep on the turkey? Or
just salt the night before in the fridge, and then after the next day, it was just lots of butter and seasoned butter that under the skin and everything. And it was just delicious the next day. Right. Obviously, the 6.5 hours at 250 helped it, right? So it's like, that's the power of the smoke with some apple chips in there. It was good. Applewood, yeah.
Look at you, man. Really, I'm sure ChatGPT helped a little bit on that process.
If this whole element thing, doesn't work out, or this whole AI thing doesn't work out, as we're talking about today, it's like we're hitting a wall. I can always go back to turkey.
You could make a killing on Thanksgiving. See what happens during the rest of the other 11 months, my friend.
That's right.
For us, similar, not turkey lovers, but turkey adjacent. So all the stuff that goes inside the turkey we love. So we had the 17,000 options of appetizers. We hosted, so we had two families coming over, and everyone comes with apps and sites. Always love that. And we just did the turkey legs, very Disney. You know what I'm talking about. Those gigantic turkey legs. So didn't smoke them, but and we did lamb. So. And yes, that I guess I would call it a 3-course meal where every like at the beginning, you've tapped out, and then you come back, and then you're like, 5 desserts, and you tapped out, and then I call it a 3-course meal because the following day was actually for me it was yesterday, because Friday we couldn't do it. Just going to town with leftovers, just the best, right? So I always enjoy the post Thanksgiving leftovers and what you do with it. Yeah, it's super fun.
Sometimes they're even better. So
well, that was a hard pivot because we just want to make sure that we catch up. We haven't seen each other, and grateful for you, my friend Ardis, grateful for the work that the company does, grateful for life, and grateful for everyone who listens to this work that we put out. It's something that we're passionate about, and I hope you benefit from it. We truly enjoy it, and we're grateful for it. So we just wanted to take that slow down and comment on it.
Here. I feel like I should do a cheers right now.
Well, these are your 11 seconds of cheerful moment while I look at the notes and see what I'm saying next. Go.
Yeah, same here. Same here. Ditto? Is that? Yeah. So whatever JC said.
Ditto. Well, speaking of slow down and basically taking a moment to reflect, there's some noise in the news outlets, technology commentators that showcase maybe a recent slowdown in performance on improvements on frontier AI models. What are we talking about? OpenAI, Google, Anthropic, the big three closed source frontier general model providers as they try to push through the next deployment. So think about GPT-5, think about where Gemini is going, and Claude, I think, is Claude 3.5 at the moment? That'll be the next frontier, Ardis?
3.5 Sonnet.
Yeah, 3.5,
yes.
right?
Yep.
So as they try to outperform their current benchmark, there's commentary that the laws of scale are not scaling. So specifically, in OpenAI, GPT-5, product name Orion, we're starting to see smaller gains in performance compared to the leaps that GPT-3 and GPT-4 came about. And the expected release that it was kind of coming towards the end of this year or early 2025 may be delayed because more testing time and compute will be needed, right? So it's a really interesting data point. I don't know if you capture a lot of Saul Altman's communication shows and outlets where he basically has comment. We have GPT-5 and even GPT-6 in the bag, right? But it's not hitting the mainstream. So Ardis, comments on this kind of noise that we're starting to hear from technology commentators and technology news outlets?
Yeah, of course. I think we talked in episode 52 when we talked about scaling laws in AI. We started the conversation on, hey, where are all these models right now, and like what's happening and what's needed there to scale these models through. But today, like as he said, we wanted to kind of approach this from continue that conversation and talk a little bit more about what that means. And, is this a good thing, a bad thing? Like, what does that mean? Does it even matter to any of us today as we're, does this frontier model things even matter to us? And, or is it more like, hey, whatever happens there, it's going to be manifesting itself in the next 4 to 5 years. So I think, and this is, now kind of recapping what we talked about in that episode 52, that the notion of, this model's kind of continuing to get better and better, they're continuing to get better and better, but the exponential improvement from GPT-4 to GPT-5 are not the same as the exponential improvement from 3.5 to 4, right? That's what we discussed earlier on. And what that means is that, because these models, cost hundreds of millions of dollars, even billions of dollars, is this notion of how much money should they put towards building this bigger and bigger models and these frontier models versus how else can we move AI forward that is not a matter of, kind of making this massive models that are exponentially better at reasoning and understanding. Does that make sense? I think that's kind of what we're talking about.
Of course, right? And on our prior work, we spoke about this triage. So it's scaling models, specifically in AI, the idea that data scarcity, computational constraints, models, the cost, all these things are at play. And what Ardis is just saying, it's the inputs that are coming in are not basically getting you that exponential output. So, one wonders, is that a problem or not? And this is basically how we want to start having this conversation about, is this slowdown good or bad? And in the midst of slowdowns, what are the good side effects, and how technologists like Ardis, myself, and many other of you who are in this ecosystem, should we start thinking about preparing for it or not? So let's start talking about the impact of slowing down, and with the premise that it feels that when 5 comes out, the expectation is not going to be that gigantic leap in performance, right? It continue to be better, but maybe it's just not incredible. So whenever it happens, so the slowdown, I think is better. It's good, right? It allows us to catch up a little bit with it. As you know, Ardis and everybody, I'm a strong believer that we underestimate the non-technological aspects of AI, the human, the process, and how we're just not catching up. So I love that slowdown so we can catch up. Specifically, think about safety. Think about the ecosystem of AI, from legal, from training, from, oh my gosh, so many other aspects. It's a really important thing for us to come and catch up, to perceive the benefits of those leaps. Does that make sense?
Yeah, no, it makes a lot of sense. So I heard, so there's a couple of things to consider here. Again, when we talk about these advancements, we talk about these frontier models, but the absorption of those models and the capabilities of the AI in the enterprise and in the work, in the companies, in our day-to-day lives is not there yet.
Correct.
Right? So we're talking like bleeding edge stuff, research that's happening right now.
If this is a score, frontier models 3, us in practice and adoption 0. Like literally that's what's happening, no?
Yeah, exactly. I think I heard something yesterday from as I follow a lot of the this podcast, and Bill Gurley, he's a very successul venture capitalist with one of the early investors. If you've seen the Uber story and the Uber documentary, so anyways, he has a podcast, B2G, and then so they were discussing kind of this idea of slowdowns, or like where are we right now, like where is Nvidia, for example, stock really good, and like how much more room does it have to go, and things like that. So as they're discussing this, the one thing that he mentioned is, look, if we could stop today, like if we can stop training this frontier models today, the capabilities that we can take from those models and where we are, it will take us another 4 to 5 years to be able to incorporate those capabilities and that AI in our day-to-day tools and get benefits out of them every single day, more and more and more. So the absorption of all this intelligence in our day-to-day and implementing it in our processes, implementing it in our work, in kind of applications that are going to be built on top of these capabilities, it's going to take 4 to 5 years for us to actually reach a limit and say, oh, now we need better models, right? It's like, it's incredible. So as you think about that, you're like, we're talking right now for capabilities that we don't really need until the next 4 to 5 years. Because we, as people who are, for example, even at Element, like we're building products, like we're okay with GPT-4. It's fine. It's great. Like it's going to take us a couple of years to build on top of that GPT-4o. So it's like, we don't need GPT-5 right now.
I had Prater spoke about that. Our reasoning capabilities on Element are actually benefiting from a frontier model that doesn't do reasoning. So if anything, it's fascinating that we cracked the reasoning aspect without getting the most advanced features in reasoning today available. So to your point, the advancement of general models, the state-of-the-art on LLMs, mostly provided by ChatGPT, by OpenAI, Anthropic, and Gemini, Google, I love that quantification in your word. The absorption, right? It's about 4 or 5 years of human power, right? And think about how do I use it, how to touch supply chain, how to touch the consumers, how does it impact vertically and horizontally the organizations. There's a nuance, Ardis, in students of management and technology innovation. You know that there's a label for these type of leaps, right, of innovation versus incremental innovation. And the opportunity of this slower innovation is that many of the new entrants catch up in a different way. For example, everyone's been talking about Apple and how does Apple catch up. Maybe there's a great opportunity for Apple to do what they need to do, right? They are leading on our privacy standards. And we've been saying that privacy and AI are not at the same level. So maybe that catch up is going to be very, very important as Apple and the product adoption and how we consumers basically perceive it and use it could give us that nuance. So can you talk a little bit before we go into the next section of how do you see these opportunities on new entrants? Because think about where you are in Element. You're leading the product. You're the architect of the technology. So Would you use this slowdown to improve in certain things, or basically do you just wait for the next gigantic drop of generic models to do what you need to do? Where are you at with that?
Oh, no. So we have what we need. Everybody has what they need right now to build
Boom.
real world applications on top of these models. Like I said, we have the capabilities over the next couple of years to keep building on this without needing any better models, right? Like the majority of the work where the value is going to get unlocked is how do you now bring these models into the application layer, into the consumer layer, into the enterprise, and start adopting it to build software on top of it. So build software with these models. You don't need smarter models to do that, right? And what the notion there is that agents are kind of this next frontier, right? This, I don't say next frontier, but how you think about software built with AI equals an agent, right? So an agent is really this approach that AI is going to kind of have access to data, and it's going to do certain tasks, and it has the smarts to do that, and it has certain context, and it's kind of integrated with your day-to-day capabilities and work. So it's kind of acting, on behalf of you or a company or whatever, and doing some useful work. So those are agents, and we don't need capabilities there. So over the next couple of years, agents are going to be, you can call them AI assistants, we call them AI assistants at Element, but this agentic workflows are going to be how you're going to unlock value from these LLMs. And the idea that companies are going to catch up, like Apple, like I'm not really worried about Apple. So because Apple, the way that they think about it is they came up with Apple Intelligence, right? So they didn't even call it AI. It's like Apple Intelligence. And the first thing that they did is, have you seen the commercials, by the way? Which essentially it's like, I don't know, like the things that we were able to do last year with ChatGPT, like, summarizing emails or shortening emails or getting the bullet points from a PowerPoint presentation or a long presentation, like all of those things. But Apple, like you see the commercial and somebody actually doing it, and you're like, oh shit, that makes so much sense, because the way that they're going to incorporate it into their applications is going to be around the day-to-day stuff. It's like, make the thing sound nicer, make it sound more blah, blah, blah. But because it's in your tools, it's in your email that you use, it's in your text messages, you know what I mean? Like now you can just pop open a menu, or like you can have AI rewrite that for you, or you can have it summarize it for you, or you can have Apple introduce like this summaries preview text in emails. It's like, I'm like, holy shit, it's like, you don't have to think about that anymore. It just summarizes that email, it produces that. So it's not that Apple is behind, is that they're working at the application layer, yet do they have to do a lot more? Do they have to build their own advanced models? Maybe, but I don't know, because that's not where their value is. Their value is in the consumer application integration, integrating that technology in that. So that's the part where I'm not worried. Like this whole game of like moving faster, moving slower. Are they behind? Are they ahead? I think it's going to, the value, who's going to win is going to be all about the consumerization and how do they capture the value from the consumer at the end of the day. So just having the best model doesn't cut it. You need to put it into a product in order to capture the value. And there's a really good article on the information this morning from the CRO of OpenAI, where they reveal that today they have about $4 billion in revenue. And guess where the majority of their revenue is coming from?
Developers, as application developers.
Nope. It's coming from, the majority is coming from the paid version of ChatGPT.
As in users, consumers, so it's their own product.
Consumers, yeah, exactly. So think about it. It's like their product is generating the most revenue, upwards to, I don't know, like maybe 3 billion or whatever. And then the APIs and the parts that they are having on the side, like access to their models, it's still low. So consumer application or the application layer still wins, right?
Incredible.
In terms of revenue. And then they're projecting their revenue to be upwards of 100 billion by 2029, right? Something like that. So it's like, where is that all going to come? It's going to come from the consumers, from the, like, of course, enterprises, like they figured it out. They're like, okay, we're going to have ChatGPT for enterprise, ChatGPT for EDU, ChatGPT for business or teams. The same thing is happening with Anthropic, right? They're doing the same kind of playbook, but it's, the writing on the wall is there. It's like the unlock of the value is going to be when consumers actually start using this stuff.
Amazing. This is, and then to the conversation about the slowdown and the impact that it has. So two things that I want to recap. Number one, it's that we've been talking about these next frontier models are way ahead of many of the things, and they can have product versions. That's what your point just recently, right? And they can have versions, and many of us are going to be deploying applications using them on those type of versions. Maybe we don't switch. 5 comes today or tomorrow, and then maybe Element decides to remain on 3.5 or whatever, technologies is being, whatever general LLM, it's powering a lot of the things that happens in Element. Your point of Apple, as Apple Intelligence, they probably are doing what they do through the application of a general LLM. Who knows which one? And this comes to my second point. What I'm hearing you talk about is that probably these organizations that they think of these that have a product, OpenAI, about $3 billion worth of prioritizing their work.
Yeah.
They create product teams, and this is where probably they go deeper onto the safety, the hallucination address. They kind of start enhancing those models, and they become also better, more solid over time, right? Now, there's something that I find really, really interesting. And this is kind of what I'd like us to pivot this conversation, right? As these organizations start basically doing two things, improving their current technology and looking at the technology roadmap, aka new models, there's also a layer of kind of narrow outputs that technologies, Ardis or many other technologies like CEOs and product experts will have to say, you know what, I'm not going to wait, but I think a more narrow deployment of an LLM, it's the right thing for me. And here, if you guys kind of go back to, 15 episodes ago, this is where we spoke about domain-specific LLMs, but it's a really interesting thing that has been playing in the conversations that, okay, general LLMs are doing this nature, it's a little bit slowed down, probably continuing innovation and improvements, but specific LLMs, domain-specific LLMs are emerging. And we see examples from Bloomberg GPT having our finance-specific LLM, PubMed GPT, obviously focusing on healthcare, scientific, computer interpreters, and things of that sort. So, Ardis, can you recap to everybody what's the difference between a general OpenAI type of LLM versus a domain-specific LLM to the ones I just kind of mentioned, Bloomberg GPT, focusing on finance?
Yeah, so I can explain that, but I also want to debunk the theory that Bloomberg GPT was actually a failure. So they put in they put in millions of dollars in developing that, and it turns out that GPT-4 was much better, the general model, than Bloomberg GPT at reasoning and answering questions. So
are you saying as you unpack that GPT Bloomberg, the application, it's a failure, or that domain specific? What are you debunking?
So I'm debunking that you called Bloomberg GPT one of the domain-specific GPTs. So the answer there is that there is a diminishing return when you're building a domain-specific GPT.
Sure.
So the way we should be thinking about this is a little bit different. But what we're talking about domain-specific is that the training data or the reasoning capabilities are for a specific domain, right?
Correct.
So you can take that you can talk about protein unfolding so we've talked about this before. And yes, those models are going to do a lot better in that, but it's not necessarily that all the training data is part of it, right? So like for certain domains, that's going to be really important to kind of train it on that data. but they still need a really large base of this LLMs, and then you can specialize it afterwards, right? So the specialization and the domain-specific specialization is very important when, in order to reduce the cost of these larger models. Because if you think about it, now you have, remember we talked last time about Einstein and having a really, really smart Einstein, and then you move it into marketing. Like we use this example. It's like, think about these large language models as very, very smart generalists, right? And then you move them into a specific domain, and now you can have them learn that domain. Well, this specialization is not happening. So it's the specialization, that's kind of what we need. It's like when they don't have to hold all of this training data around mathematics, right? Because it's never going to be used for mathematics. It's only going to be used for, let's say, creative writing, right? So why, build a really model that has all the mathematical, examples in there? Now, some people are going to say, or some folks are going to say, you still need a decent level of all of the world knowledge because of all the connections that it can make between different fields and all that stuff. But now in the next wave, we're talking about specializations of these models in specific verticals. So you get it really, really smart model, and then you can kind of continue to build its smarts around specific areas like image recognition, for example, around like cancer detection, or you know what I mean, like all of those. So you have these large data sets and you start feeding it, and it can specialize around that. So then the idea here is that you don't need a GPT-4 model, or 5 rather, to detect this cancer because you can do it with a smaller model that has just enough smarts, but you now fine-tune it, or you give it enough content on this specific area that it can become really, really good at that thing. And because of that, you now can run it much cheaper and much faster, right? So this idea of how fast these models can run and how cheaply can run, like that is starting to become very, very clear when we think about putting them in the actual applications today, right? So it's not just a matter of, hey, can you do it? Yes, but then how much is it going to cost? Like, how much time is it going to take it to give me an answer back? Like, is it going to cost me 5 cents per that answer, or is it going to cost me 1/1,000,000th of a cent, right, to produce that token? And right now, the whole industry they're working on two different kind of pipelines. One of them is, can we get the smarts really, really high? Because then we'll figure it out how to make them cheaper. And then the other one is, can we get the current smarts to produce them really, really cheaply and make them kind of the inference a lot faster so we can start adding them to our applications and can drive the cost down, because that's where the adoption happens.
Right, interesting. So at the very, very, very high level and top, we can say a general LLM, it's broad and versatile, right? And can do multiple things. A domain-specific LLM will be precise, and it's because it's task-focused. It should be designed, to your point, to be leaner and in a way more efficient, because that specificity doesn't require to train against the entire internet, right? A general LLM needs to be a lawyer, a marketer, an educator, a scientist, a wedding planner, and sometimes, a fitness coach, right? Whereas the domain-specific things ignores 55 use cases and says, I'm just going to be fantastic at recommending calories post-Thanksgiving.
Yeah, exactly. So if we can stick to that for just a little bit more, right? Like the how do they get smart? There's multiple ways that these models get smart, right?
Okay.
Smarter.
And then when you say smart, you're talking about the performance of a model. Like think about
yes, for specific tasks, right? So let's say that we wanted to evaluate transcripts, right? So like, or let's pick something a little bit more, like what? Let's pick an example. What do you think an example would be that's very domain specific?
All right, think about marketing, right? So before I needed a marketer, and we're marketing everything. So general LLM will be fantastic. But if I bring the higher education marketing angle, I could argue that in higher education you don't discount, which is one of the principles of, I don't know, general marketing. So you need to go narrow into, like, how do you message, and what is the value proposition of education versus, I don't know, selling candy. So is that a good one?
I don't know, because marketing is more, so more at the end. I think that's still very wide, right? So this LLMs can do that very easily. Like you can just put that in your prompt and you can do that. So maybe that's a really good example, right? So the way that these models
break that. Why is that not domain specific?
Sure. So the way that these models get smart, there's multiple ways, right? In order for them to accomplish a task, you have to train them, pre-training. So the P in GPT stands for pre-trained, right? So general pre-trained transformers, right? Or generative pre-trained transformers. So pre-training is one of the ways. So you can essentially, it's like long-term memory. Like you're training these models, and then you're saying, here's all the information that you have in the world, and here is all of the pre-training. I'm pre-training you to do this. So I'm baking in all the information that you need and all the smarts that you need as part of that. Right? So that's pre-training. So in our case, we can go in and we can pre-train it on, I don't know, all the marketing work of all the universities out there, plus all the literature, the internet, all that stuff. And then we can prompt it, and it's going to give us really, really good output around that. Of course, it has pre-training on a lot of different things. So pre-training is one way. The second way is through what you would call prompting, right? So prompting is the second way that you can start give him smarts, right? So as part of prompting, you can provide additional context that you can introduce new content. It's like short-term memory. So when you think about prompting, or when you think about the short-term or context, it doesn't matter if the content is coming in from like a document that you uploaded, plus or you just typed it in. It doesn't matter what the interface is, but essentially the context that you give it. So you give it context at the time that you're trying to inference, and then you're saying, answer these questions. Now imagine in your case, we load in all of the best practices for higher education, and we say, here's a whole bunch of examples, and here's all the best practices and all that, and now accomplish this thing. So that's the other way that you can kind of make them smarter. So that's when it does an inference, it produces that content. It doesn't have to be trained. You can provide the context around that, and it's going to perform really well. Another way that models can become smarter is through, if you remember prompting, we used to provide what we call chain of thought, right? We used to say, hey, answer this question, and then based on that, answer another one and answer another one. So we're orchestrating kind of the path of thinking for them as part of the context that we're providing, right? So we're saying, hey, think about this problem in this way, and we're going to kind of have the chain of thought, or like progressive prompting. That was a technique. Now, the third way is these models can reason on themselves internally. So they're pre-trained, but then at the time of the inference, you can give them a problem, and then now they have an internal process that they're generating all of those, hundreds of different variations on that process of thought, right? They're testing things out. They're generating a lot of stuff, and they have all of that in the context. And at the end, it's like it's all getting combined together to provide you the best answer. So now you don't have to pre-train it on a specific content. You can just say, hey, at the time that I'm inferencing, think about this in this way, and it's going to go back and start producing all of those things on its own, right? It's going to start thinking about, in order for me to market to colleges or high school students or whatever, I'm going to need to understand, who the audience is. Oh, it's probably going to be high school students. What do they like? How, what marketing techniques works for different variations and so on and so forth. Just like a human would go in, and if they have the general knowledge of marketing, they can now break it down for different specific areas. So that's called inference-time reasoning. And that is the one area where we're going to see, and we've been talking about this, we're going to see a huge advancement. So those are the three different ways that these models get smarter. They get smarter by building pre-training. They get smarter by the context that you provide for them. So that's where the application layer becomes really important with agents. It's like you provide the agent at every single time you provide it the right context to kind of drive them in a specific way. And then the third one is you have them do a bunch of reasoning and thinking on their own, but you still provided context, right? So does that make sense?
100%.
And of course, we have fine tuning, which is the fourth way. But fine tuning works a little bit, like pre-training, but you can provide it examples, and then you fine tune it a little bit more to say, oh, we're going to give you like maybe a very one day short memory that you're going to keep, you're going to learn for one day. And then this is the task that you're going to be doing more and more. So we're kind of driving it towards that. So the fine tuning is the last one.
Ardis, with these 4 dimensions, that all of them, right? Are you saying they all apply to general LLMs, right?
Correct. Yes. Well, actually not quite. So the reasoning one, that's a specialty one around, like for example, the O1 model from OpenAI.
In the O1, you put in a domain-specific category?
No, I put it in. It can produce really good results
Sure.
Around thinking. Yes.
I guess what I wanted to have you react to is, it sounds to me that with the right sequencing of these 4 dimensions, to use your construct of, I can get these general LLMs to be smart and smarter if you just do it the right way, I could get the benefit of what the domain-specific LLM promises to give me, which is a specialization, right? Which is they're basically very, very good at that. And your point is that, I think that's what you're saying, right? So like, look, you can achieve that. It's just that it takes the whole data in the world in a ton of compute to build these general LLMs, right? So what is the edge, if anything, for domain-specific LLMs? Is it just precision, that when I really need to understand a critical function, let's say that this is cancer detection, so I really need this to be precise, and the amount of false positive data, hallucinations, whatever you want to call the wrong output, in how it impacts the domain, is that really where you would say the edge remains? Just curious to see how you react to, wow, it seems that you can do anything with an LLM, so why do I need a domain-specific use case, if anything?
Yeah, no, so that's a very good question. And the domain-specific use cases become very useful when we have, let's say, GPT-4 models, and the performance between GPT-4 and GPT-5, they're general models. So they're very general. So they're built to, as reasoning engines, to do a lot of different things. Yeah. So now if I want to like perform something at a very high level that is above GPT-4, I need to specialize GPT-4 in that specific area. So now I need to take the base of GPT-4 and then fine tune it and build, on top of it, so I can achieve very high levels on a specific area that is faster. So all we're doing with this is that we're essentially deciding which model do we want to take as our base, and then specialize it so we can make it better. And the kind of the considerations there are, well, do I care about how good it is at giving answers? And if so, then I'm going to take the latest model that I have, like Frontier, and I'm going to fine tune it, and I'm going to get it better for image recognition in this specific area, right? And it's going to be so much better than, anything that maybe OpenAI can come up with that is more general.
Fascinating.
So that's in one way. But then the other way is like, I can get the same performance of GPT-4 with a much cheaper model if I specialize a much cheaper model. So I can get the same exact performance, but now I don't have to pay, I can pay 10 times less with this specialized model that is the base is a much smaller one. So that is the benefit that having these specialized models are helping, is in reducing the cost of deploying them and reducing the cost while still getting really high output. And that's what we're benefiting at the application layer, is that, you have models that are being built on top of Llama 3, for example, for a number of different use cases and applications, but the base model is still Llama 3, and then now they're kind of specializing it for different things. And so that's the interesting part here.
Ardis, you probably have been pitched, I don't know, 1,000 variations of AI, from annotation to, medium summarization. We're not talking about the element technology, but, as consumers and leaders, we get AI being pitched at us. Do you trust when someone says, I have a domain-specific LLM? Or do you think that's just basically the lack of understanding and it's just, the deployment of general LLM? Because in the way you just presented that, unless, I guess, I am doing open heart surgery, it seems that it shouldn't take place. So next time I have a conversation and someone tells me this is a domain-specific trained LLM, like, really? Did you go through all the necessary loops to deploy something that is cheaper?
Right.
It sounds that it would not be a logic model for any developer. Does that make sense when I'm asking you? Do you even trust? Is that possible?
I mean, there's certain areas where, like even NVIDIA, for example, they're building specific models for certain, like they're still putting out open source models out there, but there's companies that are building specialized models for specific things, and they work. But for general tasks, I'm not sure. Somebody comes in and says, hey, I'm building a marketing specific model. It's like, I wouldn't buy that, because at the application layer, if you're building for the application layer, you don't need that. Like you can accomplish what you need at the application layer by fine tuning, or by using a context the right way, or by using agentic kind of workflows where you have the model go through a whole lot of different iterations and things like that. Like you don't need it at the application layer. The only time you need it is when you're doing something very specific, a million, billions of times, and you need to reduce the cost of it, right? And you can't run GPT-4 because the cost is so high. Or you have very proprietary data sets that you need, and you can build on top of that. But even at that time, you're essentially taking an open source model like Llama 3 or one of those models, and then you're building on top of that. You're fine-tuning it with your data. So if somebody says, I'm training a model from scratch, like Bloomberg GPT, for example, it's crazy, because you're wasting a whole lot of money and you're not going to get the performance that these frontier models have. At least that's the way I see it. Unless there's something that's very specific to that, to that domain, which, of course, we know Google, for example, does all of the DeepMind with the protein folding, AlphaFold, right? So those are very good specific models, but they're still, the base of those are still Gemini based, right? They're still Gemini based, and they're just fine-tuning them for specific use cases.
So if I put together this kind of summary of a decision framework, when one is considering general versus domain specific, I think it's capturing all the different nuances that you just brought up in the conversation. Remember, we're coming from the point of view that in the slowdown of frontier general models, if you cannot wait for a GPT-5 and you think that your decision, your current GPT-4 or whatever you're using, it's not giving you the precision you need, performance needs, probably that's one of them. So performance needs, if the general model, it's not getting you there, so probably retraining, getting specificity is going to be the case. Cost and resources, Ardis has mentioned that multiple times. The domain-specific one needs to have that type of cost benefit. Although, keep in mind that you're going to go into a hyper-specialization phase, and that requires resources. So if the investment in getting up and running, that R&D, in a way, it's on you, right? And the flexibility, I think that's really interesting. What I'm hearing from you, Ardis, and what everyone should be remembering is that a general LLM is better when the tasks are likely to evolve, right? But when we are domain specific, we're looking for that precision in that field, and that error sensitivity. It's really, really cornerstone in the field. So if we keep on saying medicine, cancer, and things of that sort, probably domain specific LLM wins, right? So really interesting conversation. Ardis, coming back from the general LLM versus domain specific back to the top of potential slowdown, as a practitioner, what are you telling the teams? What are you telling the product team and engineering team of Element? Continue to build on the general LLM frontier and wait for the next ones? Are you considering a specific one because this maybe decision criteria hit some use cases? Where are you at as a practitioner?
Yeah, right now we've been really lucky that the cost of these frontier models has gone down tremendously, and it keeps going down. So every time that we're like, oh man, that's going to be too expensive for us to run at this scale, they drop the cost half or sometimes like 80% or 90%. And we're like, score, this is great. So our costs don't go up, linearly with usage. And now we are able to still use those models. So that's been really, really great. Around the speed, sometimes the speed of some of these larger models is a little bit slower than the smaller ones. So that's where we're considering things like when we need to run millions and millions of decisions, for example, when we build our proactive assistants, is like, well, how should we think about that? Because they're going to evaluate millions and millions of users every single second in order to find the best next actions and all that data. It's like, do we just build the engine with the base capabilities, or do we go with the lower model and then we start fine tuning? And that's what we're, no pun intended, that's what we're fine tuning right now. The balance between those two as we're building this and figuring out what the cost framework is going to be. So it's really going to be up to you if you're building as a practitioner. If you're building, like, how sensitive are you to cost versus because if you're fine tuning something and you're going to spend more time on that, and it's going to require more effort, and you're going to maintain your data sets on that you have to create and so on and so forth, versus like, hey, I don't care as much about the cost. I just care about getting this speed to delivery of the value. So for us, until now, it's been speed to delivery of the value, but we've been benefiting from the industry trend of getting this cost down tremendously. So we're excited what's coming next, and yeah, this is a really, really good. It's amazing kind of where the time that we're living in, and we have 4 to 5 years to go in order to get to
4 to 5 years to
before
catch
we
up
need
with
even
today.
GPT-5 plus. Yeah, exactly.
Last question on this domain of a slowdown, right? Or this topic of a slowdown. Assuming a slowdown does what it's supposed to do on the current products, improvement, is there something that you love to see on the version of LLMs that are Element, or as a consumer, like, oh, I love it, that kind of gets better? Safety, hallucination rates, anything that comes to mind that you like to see improving?
So, I mean, the hallucination rates are a little bit different in the sense that you can have grounding. You need to provide grounding, right? You need to provide the context so that they don't hallucinate. So remember when we said before, pre-training,
Yeah.
and like having that long-term memory, we don't have to do that. We can provide it as short-term memory. It gets erased every time we use it. And that's the context that we provide. So that's at the application layer. So we can provide the grounding and everything at the application layer. So these models don't really have to care too much about the hallucination part. So because we have the techniques already. So I'm not worried about it.
Okay. So is there anything from your side that you like to see improvement with the current models that we have available?
I don't think so. I mean, we like I said, we have everything that we need. We don't need anything else. The only reason, or the only thing that we need, is more more tooling around. So these companies should provide more tooling, and they can advance the tooling. For example, evaluations. It's like, how do you evaluate these models, and how do you evaluate so we're using evals, and that maybe that's a conversation for a next episode. But that's at this time you need to figure out as a company, if you're building this, how do you know that these models are giving you the right thing every single time, even though you have grounding. So you need this next phase, which is called evaluations or evals, in order to understand the accuracy of your output.
As a consumer, what I find that I'm doing in our behavior is I'm flipping between different deployments of the technology, either in web-based or using the application in my laptop or iPhone. And what I found is it's annoying for me to basically get similar responses but very different. And this idea of the replicability of the work, which is not an eval, it's just basically how sometimes the output gets reproduced differently. It's a really interesting thing of how it can be reconstructed. Do you know what I mean? That there's this aspect of, oh my gosh, I did this and can I just get it again, right? It was perfect before. It was the right response, the right substructures. And I found that to be a really interesting evolution, and now I'm struggling with it. So we'll see, hopefully, with products, you have a bit more of control on that. So, all right, Ardis, that's all we have for today. Anything else before we sign off?
I think that's it, JC. This has been, again, this is a really, really fascinating topic. I think we went a little bit long today because
it's okay. It's we usually do 45 to an hour. It's the LinkedIn ones that we try to keep under like 30 or so.
Yeah. No, this is great. So I'm really excited kind of where we are. There is no slowdown from where I stand and the value and everything that end users are going to see from this. But however, we like to give you and break this down from, the fundamental technology all the way up to like how you're actually getting use of it and how it's going to benefit you. So till next time, everyone.
Bye, everybody.
Generation AI is part of the Enrollify podcast network. If you like this podcast, chances are you're going to like other Enrollify shows too. Our podcast network is growing weekly, and we've got a wide range of marketing, enrollment, and higher ed technology shows that are jam-packed with stories, ideas, and frameworks, all designed to empower you to be a better higher ed professional. Our shows help higher ed leaders and professionals like you find their next big idea. They feature a selection of the industry's best as your hosts, like Jamie Hunt, Seth Odell, Jenny Lee Fowler, Brian Gross, and many of your favorite leaders in higher ed. Enrollify is made possible by Element 451, the next generation AI student engagement platform that's helping institutions all over the country create meaningful, personalized, and engaging connections with their prospects and students. Learn more at element451.com.